This is a video to record progress on the HBENS system that Keith and I are designing and building. Today is like February 7th, Sunday. Between yesterday the 6th on Saturday and today, I've gotten most of the drivers built for the board support and HAL layer. As you can see here, there's UART traffic coming out of the debug UART, so that we can send messages. This screen up here, I'll talk about that in a second. There's some code windows with driver code and everything. This is the UART traffic. It's 192.19.2 baud, and it's hooked up via this TTL converter here to the pins spec'd in our design. The I2C here, I'm testing it using a GY 521 board, which has an accelerometer and magnometer on it. I have Cellular Logic logic analyzer hooked up to a test pin, the LED for test, the debug pin, the NAND signal, I2C traffic, and the UART TX and RX, as well as N reset. I have channel 1 of the oscilloscope hooked up to the NAND signal. I have channel 2 of the oscilloscope hooked up to the debug test pin. Right now the debug test pin is wrapped around the I2C read in the main loop inside of the main program, in the main loop of the firmware. I've got this all powered off of my power supply using 5 volts. It draws about 0.01 amps, 0.008 amps, somewhere in there. It doesn't really register well on that power supply. I have to take measurements with a voltmeter. I'm not doing that right now. So you can see these signals here for the NAND. They're very quickly pulsing at about 5 or so hertz, 5.6 hertz. And the period, it takes about 177 to 179 milliseconds for the entire I2C to read one single register and get a value back from the chip. Now, that could change when we change chips to the list 3DH. I don't know. So as I've got this measuring and stuff, you can see there's an LED flashing here. That's the test LED. So you can see that flashing. I'm going to power it off. I'm going to restart the logic analyzer, and then I'll power it back on. Notice it's all off. Logic analyzer is waiting on the trigger, and I'm just going to turn it on, and you'll see everything start all over again. The signals come up for measurement on the scope, LED's going, UART traffic's going, and the logic analyzer, when it finishes 10 seconds of sampling, you can see that everything in the system, not just the UART stuff, but everything in the system is going. We come on power up, N reset goes high. Our test LED starts blinking. Our UART for RX, it goes high because it's not receiving anything. Obviously, the TX on the UART is going crazy as it spits out all this debug output. The debug pin, again, is going crazy. And the NAND signal is doing what it's supposed to. And the source clock and the source data for the I2C, they are just constantly reading. And if I zoom in, you can see that it's talking to it. And it's got, I gotta zoom in and out. It's kind of a pain in my ass. But I read register 75, which on this chip is the Who Am I register. So that register, when you read it from the chip, it should come back with OX68, and OX68 comes back. So it's reading. The UART's spitting out crap. Everything seems to be working pretty well, and it's a simple loop right now. We don't have the calculation in it, but this is our progress at 2100 Sunday, February 7th.